Hey folks, I'm Mr. Hartzler, and I wanted to talk to you about complex numbers and operations. It's right there on the screen, so let's get started with this. First, I wanted to talk to you about some targets and some vocabulary. So I can solve problems with complex numbers. That's the goal by the time you're done with this video, that you can do those things, or you can do that thing. The vocabulary with this, so the imaginary number, the imaginary unit, is the letter I. We use a cursive lowercase I usually, and it equals a square root of a -1. So that means I squared must be a normal, actually, let's write this down. That means that if I square both of these sides, that means I squared equals a regular -1. That's an important thing to remember, so there's that. Then the imaginary number, it often is bi, or a number and then the letter I, where I is still that square root of a -1. Complex numbers, in general, have this form right here. I'm circling it. I should circle it in something else. Let's do red. This right here in red. So it's a plus b times I, or a is any integer, b is any integer, or any real number, sorry, and then we're adding to it an imaginary number. And then complex conjugates, we'll get to that as we go, but it's pretty much the opposite of the original thing, so we'll see. All right, let's go to the next one. Solving this one, folks, we're solving a quadratic equation using square roots. So this left side, I just take the square root of both sides, right? And I have now x equals a 4. We also have to remember that it could be a -4. So I write plus or -4. I'm going to explain this just this one time because not everybody picks up on this. Let's go the other direction. So I now told you that it's x equals 4 and x equals -4. Well, let's square both of these sides. So I'm going to square this side and square this side. So that's x squared equals 16. Now on the right, I'm going to square everything, and on the left, I'm going to square everything for this other case. So again, x squared also equals 16. That's why it's a plus or a -4. Now keep in mind, that's the last time I'm going to do that, but that principle applies always. That's why we have a plus or a minus in front of all of these things pretty much for the rest of this video. All right, on the right side, right here, I square root both sides. This is where it starts to get a little shady. On the left, I have an x. I think we're okay with that part. And now I have a plus or a minus square root of a -9. But I'm going to split this up a little bit. So x equals plus or minus square root of a -1 times the square root of a 9. So inside this one right here, hopefully you agree that that's a -1 times 9. That's the same thing as just a -9, right? -1 times 9. Okay. That means I can split it up like this. And then I can piece this up a little bit. So I know that a square root of -1, I told you at the beginning, vocabulary, that's an I. And then square root of 9, that simplifies to just a 3, but I typically prefer to write it some other way, right? Always. Math teachers are weird like that. So 3i just looks a little bit prettier. I don't know why we do it that way, but we like the number than the letter. It is what it is. But if you write this one here, I understand what you mean, and we'll call that full credit, right? It's just not as pretty. Let's go on to the next example, folks. So here we're adding and subtracting complex numbers. Let me change my color. I preferred that white. I did it in the last video, and I kind of liked it. All right, adding and subtracting. We're going to only add like terms, though. So keep in mind this 4 and this 2 like terms. So -4 and a -2. I also have my imaginary numbers there of 6i. There we go. It's showing up now. And -9i. So because we're all being added, I don't really need my parentheses. They don't really do anything for me at this point. So instead of, there we go. So instead of worrying about all those parentheses, I don't have to do anything because that plus doesn't affect anything. So I can just commute these around, commutative property of addition, to wherever I want them to be. So these first two, just give me a -6. The last two here get me -3i. That's my answer. That's it. Leave it like that. It's done. I know there's a normal number and there's a 3i over there. It's fine. That's what it's supposed to be. Right? I wrote it to you at the very beginning that it's a plus bi. That's how this is written. Well, my a then just equals a -6, and my b equals the -3. That's fine. We're all still perfectly good. That's my answer. Next one, a little bit different. I actually really like that orange. I'm going to stick to that for a minute. Now, this negative matters. It gets distributed to both of these sets of parentheses. So I'm going to rewrite this. 3 minus, not a 3, 3 minus 2i plus 4, because I'm distributing that negative in, and double negatives get me a positive. Then minus I, because again, negative to a positive in this case stays negative. Now I just need to commute some stuff around so I get like terms. Now that I've commuted them around, I'll just add up these like terms. 3 and 4, and -2, and -1. And look at that. Nice and pretty, and it is done. And in this case, our A value is 7, and our B value is a -3. Both of those are real numbers, so we are all fine and good and still in the correct format of A plus BI. Cool. This right here, my answer. This right here, my answer. Let's go to the next one, folks. We're getting a little bit more complicated. I understand. We're multiplying now. So we add and subtracted. Now we're multiplying. It's going to be okay. So I'm going to distribute the thing out in front into the inside of the parentheses. So 2 over 5i times 10. I'm just going to write it like that for right now. And then minus 2 over 5i times -5/2 I. I'm distributing my 2/5 I to both things. So when we multiply fractions, we literally just multiply the numerators and then multiply the denominators and call it good. So 2 times 10 gets me the 20. 5 times 1 gets me 5. And then I still have this I that's just going to come down with me here, floating around. Next, double negatives. I'm going to change color on this so we can hopefully see where everything's at. Double negatives, so I end up being a plus. Again, multiplying fractions, numerators and then denominators. Numerators I get 10, denominators I get 10, and I times I. Well, if that was x, very few of you would have a problem telling me that's x squared, so it's just I squared. We'll keep going though, don't worry. Alright, I'm going to switch colors again, we'll go to red. 20 divided by 5 is 4. Don't let that part scare you. 10 over 10 is just a 1. And then I squared, well, I told you all the way at the beginning, I is the square root of -1. And then now it's being squared again. We're not quite there yet, so you have to take me on my word, but the squared and the square root cancel each other. That's why they're very similar names. So I end up with just a -1 for my I squared. I also wrote that in the beginning of the vocab, right? So that's actually plus 1 times -1. So that is 4i minus 1. And I can, of course, rewrite it because I'm weird like that, and I want to write -1 plus my 4i. I want to write the normal number first, and then the part with the imaginary after. I don't know why. I like it that way. Let's move on, folks. Let's do the next one. And this one has more involved. We're going to have to actually FOIL. Ooh, not erase. I want to be writing. Okay. So FOIL stands for first, outer, inner, and last. So my first terms right here. So 1/2 times 1/2 gets me, multiplying the numerators, multiplying the denominators, 1/4. Then my outer terms of 1/2 and the -2i. So that gets me -2 over 2, which is just -1, -1i. That's my inner, or sorry, now I'm on to my inner. My inner term, so I did this one now too. I'll switch colors again. My inner term is 2i and 1/2. So the 2 and the 1/2 cancel again. I'm left with just a I. And then last terms in each set of parentheses gets me 2i times -2i is -4i squared. Let's simplify this a little bit. I have an I and a -I. Those cancel right there. So I have 1/4 minus 4i squared. But we talked about this. I squared equals a -1. That is always true. I is always the exact same thing. Don't think about it like a variable. Think about it like a fancy number. So I squared equals -1. So I'm going to substitute that in. 1/4 minus 4 times -1. Double negative. So 1/4 plus 4, which is 4 1/4, or 17/4. I'm fine with either. I don't care. Ooh, part of that was cut off by my face. All right, let's go on to the next one. So you might have noticed in the last one, the last term we got, it actually canceled out all the i's, right? Well, that's because those two things were conjugates. And a conjugate just means that you took the, where's my cursor? There it is, right here. You took the exact same thing, but you changed out the sign in the middle. Notice I would go from a plus sign here to a minus sign over here. That's the only difference. It's still a -3 in front, -3 in front. a 2i in the back, 2i in the back. Only difference is the sign in the middle. So that means they're conjugates, and that means I cancel out my i's. It's pretty cool like that. So what's a conjugate for this one? 5 minus 3i. The conjugate of it would be same front thing, 3i, same back thing, but a plus in the middle. So these two things now are conjugates. Pretty easy. Let's try the next example. So we're going to simplify a quotient with complex numbers. So that means quotient right here, that just means dividing. Think about it like a fraction. I'm simplifying a dividing thing with complex numbers. So I'm dividing or a fraction with complex numbers. Here's my complex number right there. It's my I. So we're actually going to use conjugates to do that. We're going to multiply this thing, this 18, over 3 minus I by its conjugate. What is its conjugate? Well, the 3 minus I, so the conjugate is going to be 3 plus I. But you can't just multiply by any old random thing, right? I have to do it by something specific, or I have to do it to both sides, but I don't have it equals anything here, so I can't do it to both sides. But I'm allowed to multiply anything in the world I want by 1, right? Right. So what if then I multiply by a really weird, funny-looking 1? What if I multiply by 3 plus I over 3 plus I? That's a 1, right? It's the same thing on top and bottom, so it all cancels, so I get 1. I'm allowed to do that then, so let's do this. Now I'm going to have to distribute my numerator in. Ooh, lights turned off on me. Oh well. Distribute this 18 into both terms.
18 times 3 is 30 plus 24, which is 54.
Cool. So 54 plus 18i over. Well, now I have to FOIL this. So first, and then my outer, and then I'll do my inner, and then I'll do my last term. So I have to multiply the 3 to both of these things and the negative I to both of these things. And I'm going to get it. I'll zip through this, but I'll write it down. So now that we have all of that written, I need to simplify it a little bit, right? I have some I have some like terms. This one here and this one. So they actually cancel out. So I'm just going to cross them out. And then I need to rewrite it over here. But then there's another thing I can do. I told you that I squared equals -1. So let's substitute that back in. Okay, so I substituted it back in. Double negatives. So that's just a 10 on the bottom, folks. 54 plus 18i over 10. Sweet. But I can simplify further. There's a 2 in everything here. I'm going to divide everything by 2. So I'm actually going to factor a 2 out of my numerator first. I like to show this at least once so that everybody figures out what's happening, because some people will just cancel a 2 out of the 54, not everywhere else. So there's a 2 in the 54 and a 2 in the 18. So I did my GCF. I factored out. I'm going to write this down. My GCF, I factored out the greatest common factor, which actually was more than a 3, or sorry, more than a 2, but my denominator didn't have more than a 2 in it. So I factored a 2 out of the top and the bottom. Everything in the top, everything in the bottom. Those 2's will cancel, and I'm just left with this. Sweet. That's it, folks. That is my answer. The goal was to not have any i's in the denominator, and I don't have any i's in the denominator. Sweet. Let's go on to the next one. Now I'm writing the equation of a parabola in factored form. All right. Don't be too paranoid. We're going to be okay. So this here, this is the factored form. What it really just means is wherever I have an x-intercept, that's also one of my factors. So I'm kind of working backwards from some other stuff that I did in my last video. So x equals -2 and x equals -1. That comes from my x-intercepts. I'm going to draw a quick little graph here. -2, -1. Okay, so I know I hit those 2 points, and I hit the point -3, +20. So over here, way up here at 20. That likely means, right, kind of has to, that I'm doing something like this. So I know I have an a value that's positive. That's good to know. But I also know 2 of my x-intercepts, or my zeros, or my solutions, or my roots, whatever you want to call those things. I'm going to set x equal to each of those things. Now that I've set x equal to those things, I'm going to try and get those things equal to 0 instead of equal to whatever they got here. So instead of -2, instead of -1, I'm going to have them set equal to 0. So I'm going to add 2 over, and I'm going to add 1 over. So now that I have that, I'm just going to plug that into kind of this formula here. So I know then that y equals, don't know my a value yet, and then I have an x plus 2 and an x plus 1. Sweet. But they gave me another point for a reason. That wasn't just by accident. I needed that in order to find my a value. So I'm going to plug in that coordinate point and solve for my a value. So they told me my y value is 20, and I don't know my a. Lights turned back on. My x value, they told me, is -3. My x value, they told me, is a -3, and now I'm adding 1 to it. Cool. Now I'm going to simplify. Now I can go through and do some multiplication, right? This is a times -1 times -2. Let's do that. This is a times +2, or 2a, but I divide by 2. And 10 equals a. I'm kind of off the bottom of my page. Sorry, I'll write over here. 10 equals a. Sweet. Now I know everything. I mean, not actually everything, right? I just know all of the stuff that they wanted me to know for this one. So y equals my a value of 10, and then x plus 2, x plus 1. Sweet. They wanted it in this form. They specifically asked for it. So you don't have to go any farther. I don't have to FOIL all this out. Don't go and do more work than you have to, folks. Really, don't do it. It says factored. Leave it factored. It's done. Let's go on to the next one. And then I think we're almost done. So here I wrote out all of the steps already. This is all of the steps. So we're factoring a sum of squares. Difference of squares is one you've done before. It's nice and neat, but this one's not as nice and neat. And really, if you can take me on faith, then you can skip most of this whole explanation. I'm just trying to explain to you what's happening here, just in case you're curious. Because I like knowing the why, and I think some of my students do too. And Algebra 2 is a great time when we get to share with you the why stuff happens in math. So listen to the why here. The goal is this thing. I want to try and factor, and this side is factored. I want to try and factor x squared plus y squared. X squared minus y squared, way easier. X squared minus y squared. Just x plus y, x minus y. Not that bad at all, because the middle terms cancel, so it all works out. But here, there are no middle terms, but it's really hard to make them cancel. So I have to make this look like a difference of squares. That's why you see this minus sign. But you'll also notice there's 2 negatives, right? So instead of a plus, we wrote double negatives. Yeah, a -1's fine still, but I'll erase it. Instead of a positive, I wrote 2 minus signs. And that's the same thing in math and in English. It's kind of cool that way. So here, still staying the exact same. Number 1 and number 2, still equal. Then I put in a 1 because we like the 1 there. Agreed? Agreed. But I told you earlier, -1 is the exact same thing as I squared. -1 equals I squared. So I made a substitution. That's fine, because -1 equals I squared, so that's perfectly fine. Then, both of these things, the I and the Y, are both squared. So it's like, well, why write 2 twice when I can do this right here? And just write, hey, both of these things need to be squared. So we're okay. Now it actually looks like difference of squares. That is the end of detention for anybody who cares. So now I can go through and factor this just like I would any normal difference of squares like over here. And I get to this. So that's kind of the explanation for how all this happens. Let's go on to the next one, folks. So now we're going to solve a quadratic equation with complex solutions. So that means the answers are complex. And if I say complex, that means they have imaginary numbers involved. So let's do this. This one over here, I just showed you one way, right? So if we go back to that, yeah, I know that I can do this, but with imaginary numbers involved. So this left side, if you want to trust me to take that formula, well, x plus 7i and x minus 7i. There's another kind of a little shortcut way, almost. So if I subtract the 49 over. So I'm not really supposed to do this, but you can kind of do this. If you square root both sides, then you get x equals plus or minus, of course, the square root of -49. But we're not going to write that. We're going to write a negative 1 times 49. And we're allowed to split that up. So plus minus square root of negative 1. Oh, I wrote too big of a square root. Square root of a negative 1 times the square root of 49. Well, that gets me plus or minus 7i, because 49 gets me to 7, and square root of negative 1 is I. I told you that earlier. And we can, of course, then add that back and get to what I wrote right here. And because here, I'd actually have to set that equal to 0 and solve each piece, and you get this. Let's do that on the right side as well. So I'm going to subtract my 25. So 9x squared equals negative 25. Just divide by 9. X squared equals negative 25 over, oh, I wrote 29. Negative 25 over 9. Well, now I need to take the square root of both sides. Gets a little shady here, right? So x squared, no, just x now, right? Equals, I think we're okay with the plus and minus at this point. Square root of 1, negative 1, times 25 over 9. Hopefully you're okay with me splitting it up like that, right? Then I'm going to do just like last time. Square root of a negative 1. Oh, that's I, isn't it? So that's I. And then square root of 25 over 9. I can do this without a calculator. I don't give my students calculators yet. Not till we get to trig, folks. What's the square root of 25? I can do just my numerator than just my denominators. What's the square root of 25? 5. What's the square root of 9? 3. You can do this, and you can do this without a calculator. You really can. All right, done with this one. Next. Oh, wait, that's it. Don't forget to like this video, folks. And, of course, don't do drugs. That's all I got for you today. Enjoy your day, and hope this was helpful. Bye, folks.